I'm Anil Kumar. Welcome to my series on mechanics. In this video, we'll consider Newton's laws of motion and we'll take up an application which is based on stopping distance of a car and coefficient of friction. In case you want to learn from me, you can always send an email on the address given. Also, check our website for the latest updates. Now, let's look into the question. On a level road, the stopping distance of a car traveling at 60 kilometers per hour is 24 meters. Find the coefficient of friction between the tires and road. Find the stopping distance if the road going downhill at an angle of 8 degrees. You can always pause the video, answer the question, and then look into my suggestions. Let's try to understand this situation. Well, in this particular case, we are given two different situations. One, the car is traveling on a level road, right? So one is the car is traveling on a level road. The other one, it is going down the hill, right? So these are the two different situations which we are talking about. How do we solve such a question? Well, in the very first one, when it is traveling on the level road, we are given the stopping distance. So let us say that uh, the the car is right here and it is traveling in in this direction, for example. Correct. In that case, the frictional force will be acting against, and that becomes the frictional force F. Correct. And this frictional force will make the car stop at a distance given in this particular question, right? So let us say it stops after some distance, right? So that is the first situation. So we know from this particular situation that using our uh, equations like v square minus u square equals to 2as, we know final velocity, initial velocity, we know the distance, we can find acceleration from here, right? So acceleration will be equal to v square minus u square over 2 times the distance given. Now this acceleration which we have calculated from the given situation, which is right there, right? We know the velocity, initial velocity, right? We know the initial velocity and the distance. And we also know the final velocity will be zero, right? So the final velocity is going to be zero. So all the things on the right hand side are known to us. Well, substituting zero here, we get minus u squared over 2s. So that is clearly deceleration, which is helping the car to stop. Now, how do we find the coefficient of friction? That is the question, right? Find the coefficient of friction between the tires and road. So this coefficient of friction is from the Newton's second law. We'll find the net change in force. Now, in this case, the net force is F, and this force is actually equal to the normal force times the coefficient of friction, right? So that is what it is. And what is the normal? Normal is mass into gravity. So that becomes the frictional force. And this frictional force, when divided by the mass, is acceleration. So that is how they are related, correct? So we know that acceleration is related with this frictional force, which is F of F over mass m. And from here, we can find what mu is, right? So substituting, we get mu g as, m and m will cancel, correct? So let me write like this. So we'll get this mu g from here. And of course, this frictional force always acts in the negative direction, and therefore we should use negative sign here. That is the net change in force, right? So it is acting against the motion. And therefore, we can actually find mu from here, right? So the only unknown is mu, which we are able to find from this particular expression. So that is one part of it. So basically, what we have done here is that we have found the frictional force between the tire and the road. Now, in the second case, what we are considering is, let's say the situation is that now the car is going down the hill. Now, in that case, what is going to be the stopping distance? So that is the part two. So in part one, let's call A, we find mu, and in part B, we find stopping distance, right? Since it is going downhill, it has to be more than the previous case, correct? Now, how do we do that part? That is what we have to look into. Now, since the car is moving down the hill, in this particular case, you can draw your free body diagram. Now, it is the force which acts downwards will be mg sine theta, correct? If this is the angle theta for us, right? So that is the mg sine theta. Now in this particular case, the normal, let's say Fn, is equal to mg cos theta, correct? So that is the Fn, and in this particular case, the friction will act in the direction opposite to this. So the net change in force in this particular situation is what? Is basically change in these two. That means mg sine theta minus Fn. So the net change, let's say sigma F in the direction of the force, is basically equals to mg sine theta minus Ff, right? And frictional force, as you know, is mu times Fn, so which is equals to mg sine theta minus mu times mg cos theta, correct? So from here, you can find that this net force is basically equal to the mass into acceleration, right? So this net force is ma, and relating A with the given situation, we can actually find the relation, correct? So again, we can use the same type of equation. So it's a reverse calculation to what we did earlier. We can go like this and find the stopping distance, correct? The reverse order we can follow. You get the idea. So that is how we are going to solve this question. I hope it is perfectly fine. You can actually pause the video at this stage and solve the question and then look into my suggestions. Now let's see. So here are the calculations done as per our discussion. So the question, as you see, is on a level road, the stopping distance of a car traveling at 60 kilometers per hour is 24 meters. Find the coefficient of friction between the tires and the road. So first part is to convert the velocity in meters per second. We're given velocity as 60 kilometers per hour. So when you multiply by 1000, you convert kilometers to meters, and multiplying by 3600, we get hours into seconds. So that is how we get 16.67 meters per second as the velocity of the car traveling on a level ground. Now, force of friction is the net force that will stop the car. We are given the stopping distance of 24, right? Now, this force of friction has to be negative as we discussed, and it is equal to mu times the normal force, which is mg. So mu times mg is the frictional force. So therefore, the net force which is acting on the car is minus f of f divided by m gives you the acceleration. So we have an expression for acceleration in terms of coefficient of friction mu, right? So a is minus mu g. Now we are given the stopping distance of 24, and from there we can actually calculate the value of mu, right? So that should give us the value of mu. Now from the given situation, we can say, well, we just found that acceleration is minus mu g. Initial velocity, just converted into meters per second, is 16.67. Final velocity is 0, and the stopping distance is 24 meters. The expression which helps us evaluate or relate all these parameters is v square minus u square equals to 2as. You can substitute the values and get your answer, or you can derive a general expression as I did. So in this particular case, you can isolate mu, the coefficient of friction, as minus of v square minus u square over 2gs. Substituting the values, we get the value of mu as 0.59. Do you see that? Now, it is very important to understand once again that the stopping distance is independent of the mass, correct? Now, let's move on. We know now that the coefficient of friction in this case is 0.59, correct? So, let me write down. We just calculated the coefficient of friction in part A, which is 0.59. So, let's take it over to the next part. So, we know mu equals to 0.59. Correct? Okay. Now, let's look into the second situation where the car is going down the hill. Now, when it is going down the hill, the weight is acting downwards as mg. Normal force, normal to this slope is Fn and mg cos theta. They balance out. So Fn is basically equal to mg cos theta. The frictional force is equal to mu times F of n, and so we get frictional force as mu times mg cos theta. What is the net force? The net force F is the difference between mg sine theta and the frictional force. So the net force here is mg sine theta minus Fm. So F is a net force, right? Or you can say sigma F. So net force is mg sine theta minus F of F. Now, substituting F of F, which is mu mg cos theta, we get net force as mg sine theta minus mg cos theta. And now, we also know that F is equals to ma. Substituting, we can get our result, or we could also use the formula that A equals to net force over mass, right? Which gives you the formula directly. Perfect. So mass gets cancelled away and you get acceleration as g sine theta minus mu g cos theta, right? So either way you work, you get this expression for acceleration. Now once you know acceleration, you can, the expression for acceleration, you can substitute this into one of your 5 important formulas. V square minus u square equals to 2as is a very important formula which relates velocities with acceleration and distance or displacement. So s can be isolated as v square minus u square over 2a. A is g sine theta minus mu g cos theta. And that gives you a general expression, a very important general expression to find the stopping distance, right? So that becomes a general formula. Well, of course, you could write velocity as 0. So you get minus u square over 2g sine theta minus u cos theta as your formula, right? Substituting the values, we get the stopping distance as 31.8 meters. You get the idea, right? So see what? Earlier, the stopping distance was 24 meters. Now it is 31.8 meters, right? So when there is a slope of, in this case, 8 degrees, do you know by how much the stopping distance has increased? Well, let's try to figure this out. Well, 31.8 minus 24 is change in the distance divided by the initial distance times 100, right? So multiply this by 100, you get, let's say that is in percent, right? So you can actually calculate this answer and it comes to more than 30%, right? So so that is the great increase in stopping distance when there is a slope involved or in hilly areas. So we need to take care of it while driving on slopes or on hills. So I hope that brings you to a very good application and I hope the concept is absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.